Hey Team Bio, welcome to your welcome to your screencast, The Greenhouse Effect, Part 1. This is a topic that you've probably all learned about in school before, how the greenhouse effect is contributing to climate change. But over the course of the next two screencasts, we're going to really dive into some of the chemistry and physics behind the greenhouse effect. So hopefully you'll really understand what is happening by the end of this week. Okay, so we're going to start off talking about light. Light and understanding light is going to be super important to understanding what's happening with the greenhouse effect. Okay, so light comes in many different flavors. When you think of light, you're probably used to thinking about the visible spectrum, what we can see. But visible light is actually only a very small band of the entire electromagnetic spectrum. So here is the rainbow. Here we have red, all the way down to indigo or violet on this side. And if we combine all these lights together, we would see white. If we mix red, green, and blue, we get white. And the absence of light would be black. But again, this is visible light. And if we look at the entire spectrum, the entire electromagnetic spectrum, we see that visible light is only a tiny, tiny, tiny slice of all the light that exists out in the world. But we can't see it. The only light that we can see is this little small slice of the electromagnetic spectrum. Okay, so what is going on with all these other different types of light? Well, if we were to take the electromagnetic spectrum and break it down into the characteristics at one end versus the other, we see on this end, we have small wavelength, high frequency, high energy, high energy per photon of light. We're not really going to get into wave-particle duality here, but know that light can act both as a particle and as a wave at the same time. It's really surprising and kind of confusing. So we're not going to talk about it here, but know that this end of the spectrum, we have small wavelength. This means if we were to count the distance between two peaks, we see it's very small. If we were to count the number of peaks that occur over a certain time period, we'd see a lot of them. And every photon of light at this end of the spectrum is very high energy. Now, if we go down to the other end of the spectrum, we see that here we have large wavelength, low frequency, and low energy, ERGY, low energy light on this end of the spectrum. Okay, and once again, the only light that we can see is this little band of the spectrum, but this entire spectrum goes all the way from gamma rays all the way down to radio waves. And as we move across the spectrum, the frequency, how many peaks occur over a time interval, and the wavelength, the distance between the crests or the troughs of the wave, increases as we move from here to here. And these waves lose energy. Okay, so some of this type of light you might be familiar with. If you ever had an X-ray, then you have been exposed to this type of light in a large quantity. If you've ever had a sunburn, it was the result of ultraviolet light. If you've ever felt warm, in front of a fire. You are experiencing infrared light or heat. Or if you just touch the back of your neck, you'll feel light emitting from your body in this spectrum. Of course, we see visible light all the time. And then here we have radio and TV and FM AM, and also Wi-Fi is on here as well. Microwaves we use to warm up your food are right in here as well. Okay, so you interact with all this different type of light all the time, even if you don't know it. And in reality, all matter is emitting light. All matter emits light. But the wavelength of peak emission of light, all right, I'm just going to write this all down. So the wavelength of peak emission, so the light that matter gives off, is inversely proportional to the temp of the emitting object. So what does this mean? It's a kind of a fancy way of saying hot things emit small wavelength light, and cold things emit large wavelength. Light. Okay, so if you think about the electromagnetic spectrum for a second, the type of light that we see all the time is mostly from the sun, and it is in the visible spectrum. So the sun is emitting all frequencies of light, but the preponderance, the most light that it emits is within the visible spectrum. So here, the sun is emitting this. And the sun is pretty hot. Not the hottest thing out there, but it's pretty hot, and it's emitting things in the visible spectrum. You are not as hot as the sun, and so you are emitting light all the time in the form of infrared light. So the sun is a hotter body than you. It emits visible light. You are emitting infrared light. Mostly. You also emit all the frequencies of light all the time, but most of the light that you are emitting is infrared. The sun also emits everything, but most of the light it emits is within the visible spectrum. Okay, you have seen this in action all the time. You know that when you heat stuff up, sometimes it starts to glow. So here we have something that is hot, very hot. And as you've heated this metal up in the forge, you've increased its temperature, and now it's gone from emitting a wavelength of light that you can't see to a wavelength of light that you can see. Now it's in the visible spectrum. So as you heated it up, now it's emitting something with a smaller wavelength of light. These other pieces of forged metal, they're also emitting light, but they're not quite as hot. So they're emitting infrared light. If you were to scan these things with an infrared camera, you would see that they have they are emitting light, actually. So this is emitting visible light. And this is not as hot. And it's emitting IR light, or heat light. Okay, here are people. You would not think of them necessarily as emitting light, but they are emitting light. They're just emitting heat, IR light. So this is IR light. And you can wear night vision or infrared goggles and see the light that people are emitting at night or during the day. And the same thing is true for any living thing that has a temperature that is not absolute zero. These things are going to be emitting different frequencies of light. So here are some birds with also emitting IR light. Okay, so that's the first big takeaway, is matter is emitting light, and the light that it emits is based on its temperature. Okay. Okay, the second big idea is that when light interacts with matter, three different things can happen. When light interacts with matter, it can be reflected, so it can hit that matter and then bounce off. It can be absorbed by that matter, so it can hit the matter, and instead of bouncing off like it does when it's reflected, it is absorbed by the matter, and now that matter contains the energy of the light. Okay, the third thing that can happen is that light can hit matter, and it can pass through the matter, and that's called transmission. Okay, so when light can be emitted by matter, and then when it interacts with matter, when it comes into contact with new matter, it can either be reflected, absorbed, or transmitted. And the type of light that you have, basically, how do I want to say this? The type of light and the type of matter that you mix together, you'll either see one of these three things happen. And different types of light, when they act with different types of matter, they behave differently. Okay, so what do I actually mean by that? If you have a piece of glass, say, we use glass to let visible light in. So the glass is transparent to visible light. So this is visible light. I don't know why that's not drawn on here. This is in the visible spectrum. So the reason why we choose glass as a building material is because it has this property. It transmits visible light. So glass transmits but glass does not transmit infrared, so heat, or ultraviolet light. So it's impossible actually to get a sunburn behind a pane of glass, like in your car. You can't get a sunburn if you have the windows up. If you roll the windows down, all bets are off. You can get a sunburn. So the glass absorbs ultraviolet light and it absorbs infrared light, but it transmits visible light. Okay, so that's a property of glass. A property of bones is that they absorb X-ray light. So the reason why we use X-rays to tell what's going on with our bones is that X-rays pass through most of our soft tissue. Like here you can see the outline of this person's hand faintly. Most of the X-rays are being transmitted through their hand, but the calcium that's in bones absorbs X-ray light. So here we have an example of an X-ray which is transmitted through flesh, but it is absorbed, by bone, which allows us to see the bone show up on a photograph image of the X-ray. This remains unexposed, and this part gets exposed to the X-ray, which causes this nice contrast that we see and allows us to visualize the bone. Okay, so that's important. The bones absorb the X-ray, and then the soft tissue transmits the X-ray. Oops. But then this is in contrast to visible light, which is totally absorbs all visible light. So if you take visible light and you shine it up to someone's hand, we see that light is absorbed and also reflected off of their hand. So visible light visible light is absorbed or reflected off a hand. It is not transmitted. Okay. And then here's another example of two different types of light. Here we have a light that is a visible light coming from a lamp in a room, and you can see that the two lights are on and we're filling this room with light, but here we have a wall, and the wall reflects the visible light. So the wall is not transparent to the visible light. It stays in this room. But here in this other room, we have a Wi-Fi device creating Wi-Fi waves, and the wall, which was reflecting visible light or absorbing it, is transmitting Wi-Fi light. So the wall reflects and absorbs visible light, and it transmits Wi-Fi, which is another type of light. And you all have definitely experienced this. You know, if you're in another room, someone turns on the light, the doors are closed, the visible light will not pass through the wall. However, the Wi-Fi making device can be in the other room, and you can use your cell phone or your computer in that space, even without directly seeing the device, because your eyes, they can't see through the wall. They can only see the visible light, and the visible light is not passing through the wall. However, the Wi-Fi waves are passing through the wall. So the big takeaway here is that different types of matter interact with different types of light differently. And depending on the type of matter that we're talking about, you might get reflection, or you might get absorption, or you might get transmission. And if you change the type of matter, then you're going to change the property that, or the way it's going to interact with the light. Or if you change the type of light, you're going to change how it interacts with that type of matter. Okay, so hopefully this all made sense. This idea that different types of light interact with different types of matter differently. And that's all going to come together to help explain climate change in part 2. Okay, that's all.